everyone, welcome back to our channel, that is Chemical Engineering. Myself Dr. Kirti Zare. Today I am going to introduce you about the Newton-Raphson's method. There are the different type of the applications of this Newton-Raphson's method, which can be including into the optimization of the different process equipments, different process of the molding and the simulation into the solving the engineering complex problem, also into the physics which can be utilized into the differential form of the equation, also utilized into the computer graphics in the form of the X-ray or in the form of the surface, also used into the economics and the financial models where you have to optimize or you have to predict the some things in the future. So there are the different type of the applications of this Newton-Raphson method. So let us start for this numericals. So the numerical statement they have mentioned, using Newton-Raphson method, you have to take the initially guesses as the 0 to find out they are giving this function, that is the x cube minus 5x plus 3, and they are asking for the 3 iterations over here, right? So let us start for the solving of this particular type of the numericals through the Newton-Raphson method, right? So initially cases you are going to consider they are giving the x1 as the 0, right? Now they are giving the function, that is the f of x is equal to the x cube minus 5x plus the 3, right? While you are going to solving the any particular type of the numericals, whether it can be deals with the mathematical subject, whether it can be deals with the any particularly field, like in the chemical engineering, maybe solving the heat transfer, mass transfer, diffusion, concentration, molar ratio, mole fractions, or maybe the reaction engineering, maybe the dynamic, maybe the controlling, or the doing the modeling or the simulations of anything. So firstly you must be recognize that what is exactly the problem statement they have mentioned and what are the different given data they have mentioned into the numerical statement. These are the all different type of the methods are helpful to solve the whatever the industrial or whatever the real problems is there, right? So with respect to that, they are already mentioned this function, they are giving the initial condition x1 is equal to the 0. Now to finding the to find out the f of x, or whenever you are find out the for the 3 iterations accordingly the Newton's-Raphson method, that is the xn plus 1 is equal to the xn minus f of xn divided by the f dash of the xn, right? So this is the simplified form of the Newton's-Raphson's method, right? Which is the n is denoted as x, means simply that whatever in the form of the functions they have mentioned, right? Sometimes you are also observed that they are given the f of x, f of y, means that is the function with respect to that they are given the equations. If you are going to talk about the same problem in the thermodynamic subject, so might be they are giving in terms of the temperature, in terms of the pressure, in terms of the mole fraction which is present into the liquid phase, in terms of the y, that is the mole fraction which present into the vapor phase, right? So there are the different assumptions or the significance of that particularly term with respect to that particularly subject, right? So that is nothing but they are just denoted that it is a function of a what, and here is denoted as the how much iteration that you want, right? Or n is denoted that you are starting with the first iteration, second iteration, third iteration, so you are supposed to put the value of n over here with respect to the iterations. Xn, again n is the iteration, as x only they are giving in the form of that particularly function, right? F of xn means you have to take the function, means whatever the values that you are supposed to consider in the form of n, the same value you are supposed to consider or put into the function of f of xn. So here you are supposed to consider this is the f of xn means this is our given statement or the given problems. Again f dash of the xn which can be denoted as the derivatives of this particularly form of the function, right? Now here only one dash is there means you have to take the only one derivative. In some of the numericals or in the some of the problems you are supposed to consider the 2 dash, that is the 2 derivative means you have to consider the second derivative of that particularly functions. Means firstly you have to do the first derivative and secondly you have to do the second derivative and so on. Now they are going to ask that you have to complete for the 3 iteration, right? So for the iteration number 1, so you have to suppose to consider the n become the 1 at the initial condition xn. So xn means you are supposed to consider the x1 that become the 0. So do the calculation, that is the xn plus 2 and value become the 2, right? Means 1 plus 1 it become the 2. So you are supposed to calculate the x2 over here. X1 means x1. So you have to put up the direct x1 value over here and function of the f of x1, right? And divided by the function of the derivatives of the x1. Now x1 value become the 0. So you have to put the 0 value in our main function. And you have to take the derivative of this particularly function and you have to whatever the form of the equation will be getting after the derivative of this. So in that you are again put the 0 value, right? F of x that become the, you are supposed to put the 0 value. So into this function. So 0 cube become the 0 minus 5 into x become the 0 and you are getting the value become the f of x become the 3, right? So f dash of the x, that is nothing but what? 3x square, right? Here that is the minus 5, right? So this is the simple derivative of this. Now you are supposed to put the value over here, that is again this become the 0 and you are getting the value that is the minus 5, right? So now you have the 2 value, you have the again x1 value. So you are supposed to calculate the x2 from here, right? So now x2 that is become the x1 value become the 0 minus f of x become the 3 divided by, hence it is in the minus, so that's why I am going to put into the bracket. So if you are going to solving this, you are getting the x2 value, become the 0.6, right? Now generally they are already mentioned that how much iteration you want to do, but in the sum of the numerical statement they are not mentioned, so you have to go for the nearby value of this x, right? So just go for the second iterations, right? So for the iteration number 2, now you are getting the this value become the new value of the x. So you are supposed to put the 0.6 into the this equation. 0 you have to supposed to put the 0.6. Now just go for the iteration number 2, right? So similarly manner you are supposed to consider the this formula, that is now this become the, you are supposed to consider the n become the 2, right? N become the 2. So you are now this value become the 2 plus 1 become the 3, right? Xn means again x2 minus f of x2 into the derivative of the f of x2, right? So same manner x2 of the x2 value become the 0.6. Now the function of the x2, right? You have the x2 value become the 0.6. So you have to quickly put into the 0.6 cube minus 5 multiply by the 0.6 plus the 3. If you are also you are getting the value 0.216, right? Similarly manner you are supposed to calculate the derivative of this x2. So that is nothing but the 3x square minus 5. So that is equal to 3 multiplied by 0.6 square minus 5. So you are getting the value become minus 3.92. right? Now you have the all value over here. So just quickly put up here, that is the x3 become the 0.6 minus this value become the 0.216 divided by minus 3.92, right? Solving this, so you are getting the value become 0.6551, right? So this is accordingly the second iteration. Now just go for the third iteration. So if you are going for the iteration number third, so for that similarly you have the this new value of the x3 here. Now your again consider the n become the 3, right? So here put this into the main formula, that is the 3 plus 1 become the 4. So x4 is nothing but the x3 minus f of x3 divided by the f dash of the x3, right? So now you have the this x3 value, but you are again supposed to calculate the f of x3 and f dash of the x3, right? So quickly calculate it, f of x3, that become the, again you have to put this value, that is 0.6551 q minus 5 into 0.6551 plus 3, right? Of the x3, so that is simply become 3 multiplied by 0.6551 square minus 5. If we are going to solving this, f dash of the x3 will become the minus 3.0347, right? Now you have to just put the value over here into the x4, that is equal to the x3 value 0.6551 minus this value, that is equal to 5.62 multiplied by 10 raised to minus 3 divided by minus 3.0347, right? You are getting the x4 value, with the x4 value become the 0.6569, right? So x4 value become the 0.6569, right? As in the numerical statement, they have mentioned that you have to solve up to the 3 iteration. So you are supposed to complete this up to the 3 iterations, right? Generally, depending upon the tolerance or the how much error is given or how much accuracy is required with respect to particularly numerical, you are supposed to do the simply iterations over there. I hope so that you understand this Newton-Raphson method. So please like, subscribe, share my channel. Thank you so much for the watching.